Welcome to the Explainer. Okay, today we're taking a deep dive into what is absolutely the most underrated, yet arguably the most powerful primal organ in the entire human body. Yep, we're talking about the nose. Seriously, we are going to completely change how you view your sense of smell. I mean, think about this for a second. What do a French pastry, a psychopath, and a Parkinson's diagnosis all have in common? I know, it sounds like the setup to a really bizarre joke, right? But stick with me because by the end of this explainer, we're going to see exactly how these three completely unrelated things are tied together by the hidden invisible world of scent. All right, let's jump right into section 1, the secret of smell and memory unlocking the past. So, you know that moment, right? You catch a whiff of a specific perfume on the street, or maybe the smell of rain hitting hot pavement, and instantly, boom, you're transported back in time. Well, this phenomenon actually has a name. It's called the Proust effect. It's named after the French writer Marcel Proust. In his famous novel, the main character dips a Madeleine pastry into his tea, and that scent instantly unlocks this massive flood of childhood memories. Now, here's the absolutely crucial difference between smell and sight. When you look at an old photograph, it's mostly a mental exploration. You remember the facts like, oh, I was wearing a red shirt, we were at the beach. But when you smell a scent from your past, you don't just remember the facts, you literally relive the exact emotion. You feel the exact same joy or comfort or even fear that you felt in that very moment. Smell doesn't just retrieve data, it retrieves feelings. So, why is smell so special? Well, it all comes down to section 2, the only sense connected directly to the brain, the anatomy of emotion. Let's look at the biological plumbing here. When you see or hear something, that sensory data travels into your brain and hits this gatekeeper called the thalamus. Think of it like a security checkpoint. It analyzes the data logically before sending it out to the rest of the brain. It's a very rational, organized process. But smell? Smell doesn't deal with security checkpoints. The olfactory signal bypasses the thalamus entirely. It takes a direct, unedited, high-speed highway straight into the amygdala, which is your brain's emotional center, and the hippocampus, which manages your memories. It's the only sense that does this. It triggers your emotions before your logical brain even realizes what's happening. To understand why our brains are wired this way, we actually have to travel way back in time. Let's look at section 3. Survival instincts left by evolution, the ancient wiring of the nose. Smell is literally the oldest sensory system in evolutionary history. I mean, long before creatures had eyes to see or ears to hear, single-celled organisms used a primitive form of smell to navigate their world. They basically needed to know, hey, is this sweet, meaning nutrient-rich, or is it bitter, meaning toxic? Because it was our very first survival tool, it's designed to be incredibly fast. Imagine you're out in the wild and you suddenly smell a predator. You definitely don't want your brain to pause and logically analyze the situation. No, you want your amygdala to instantly trigger pure terror so you run for your life. That instant, gut-level reaction is what kept our ancestors alive. And hey, we aren't the only ones who rely on this deep-seated biology. Think about salmon for a second. After swimming thousands of miles in the open ocean, how do they find the exact same tiny stream where they were born just to lay their eggs? They don't navigate by the stars. They use something called olfactory imprinting. They literally smell their way home, detecting the exact chemical signature of their birthplace water. It's wild. All right, so we know smell is ancient, and we know it's deeply emotional. Let's test what you actually know about your own nose in section 4, Surprising Truths About Smell, Fact versus Fiction. We're going to do a quick quiz here. Here is your first question. Does our sense of smell decline with age? We all know vision gets worse, hearing gets worse, but what about smell? Go ahead, take a guess. If you guessed yes, you hit the nail on the head. Now, the olfactory cells in your nose actually regenerate throughout your entire life, which is incredible when you think about it, since they're directly exposed to the outside environment all the time. But as we age, the speed of that regeneration slows down significantly. In fact, our sense of smell often degrades even faster than our vision. And this is actually a massive safety issue for the elderly. Sadly, many tragic accidents happen simply because older adults can't smell a gas leak in their kitchen or smoke coming from a fire. Okay, let's try question number 2. We all know dogs have literal superpowers when it comes to their noses. Some dogs can detect over 100,000 different scents. So, can a highly trained tracking dog distinguish the sweat of identical twins after they've both been working out? The answer is actually no.
I know, this completely blew my mind. Natural body odor is fundamentally determined by our genetics. Because identical twins share the exact same DNA, their base body odor is perfectly identical. So unless one twin went and rubbed perfume on themselves, even the absolute best tracking dog in the world cannot tell them apart based on natural sweat alone. No way.
Moving on to question 3, and we're finally touching on that second part of our opening hook. Do psychopaths have a good or bad sense of smell? The answer is they actually struggle significantly to distinguish scents. Now, we are neutrally looking at brain biology here. Psychopaths simply have a different anatomical brain structure, particularly when it comes to how their brains process emotional and sensory data. It's not that their noses are physically broken. They can absolutely detect that a smell is there. But because smell is so deeply, intimately tied to the emotional processing centers of the brain, which, again, are wired differently in psychopaths, they severely struggle to distinguish between different scents or clearly identify what they're smelling. All right, final quiz question, and we're pivoting to something we all love, food. If you sit down for a meal, put on a blindfold, and pinch your nose shut, how much of the flavor do you actually taste? You lose 80% of it. That's right, 80% of what we consider flavor is actually just smell. Your tongue can really only detect basic profiles, sweet, salty, sour, bitter, and umami. The whole rest of the complex flavor profile happens up in your nasal cavity. In fact, if you're blindfolded and holding your nose, you literally cannot tell the difference between biting into a raw, crunchy onion and a sweet, crisp apple. They feel exactly the same in your mouth, and without smell, your brain just cannot tell them apart. Okay, let's move into our fifth and final section where the science truly feels like magic. Section 5, Detecting Diseases Through Smell, the Medical Miracles of the Nose. And this ties right back into the final piece of our opening mystery about that Parkinson's diagnosis. Here's the thing. Every single time you exhale, you aren't just breathing out carbon dioxide. You are exhaling a highly complex cocktail of chemical compounds produced by your body's metabolism. Medical science has found that diseases alter this chemistry in very specific ways. Patients with advanced diabetes, for example, exhale compounds like glucose and acetone, which ends up smelling strongly like a magic marker or nail polish remover. Lung cancer can actually produce a scent similar to paint thinner, and breast cancer can sometimes smell like rubbing alcohol. It turns out our bodies are constantly broadcasting our health status right through our scent. And the most astonishing real-world example of this comes from a British nurse named Joy Milne. Her husband was diagnosed with Parkinson's disease. But here is the incredible part. Joy noticed a distinct change in how her husband smelled, this strange, musky, earthy scent, months and even years before he ever showed clinical symptoms and was officially diagnosed by doctors. When scientists rigorously tested her abilities, they found she could accurately identify who had Parkinson's just by smelling the t-shirts they had slept in. So how does a brain disease physically change how your skin smells? Let's walk through the biology real quick. Step 1. Parkinson's begins to alter the brain's function. Step 2. Because of the highly connected brain-gut axis, these neurological changes actually affect the microbiome of bacteria living in your stomach and intestines. Step 3. This bacterial shift causes your entire body's metabolism to change. And finally, step 4. This altered metabolism produces specific chemical compounds that are secreted right through your sweat and sebum, the natural oils on your skin. Because of this, scientists are now actively developing a simple skin swab test to detect these exact chemical odors. This could potentially allow us to diagnose Parkinson's years before major symptoms appear, all thanks to the power of smell, a real game changer. So, we've seen how smell unlocks our deepest memories. It operates as our oldest survival instinct, connects directly to our emotional core, and even acts as an invisible billboard broadcasting our health. So I want to leave you with this final, lingering thought to ponder. If the nose truly is the window to the brain, what is your sense saying about you right now? Thanks for joining me on this explainer.